Okay, so now that we know what you're going to do, now that you know how to navigate in that complicated movie in the beginning, when you know all these different things, we can start trying to start testing hypotheses. Yeah. So for example, we can ask what is the ask this question: what is the distribution of the different spots during development? So I'm showing you. So the idea is one with good question that we can ask. Let me go back. Is imagine that you have time 1, time 2, and time 3. Yeah. Are those spots appearing all at the same time? They appear individually. They appear at random times. Are they? Yeah. This can give us some information, like where maybe if the peripheral membrane just broke, maybe all of them should appear at the same time. Yeah.
Okay.
Maybe why there are some that are so big. Maybe the big ones appear at some time. Maybe just to know, start making this type of questions. Yeah. So one of these questions that I wanted to propose is this: the distribution of these different spots, and we can do spatial and temporal. Let's start first with temporal. Yeah. So we can quantify groups of individuals and group of cells, and you can do a different. Slowly, you will start proposing your own hypothesis. Yeah. I just generate this hypothesis and I generate these groups based on what I see. Yeah. What I saw is the following thing. I saw individual cells, individual spots many times. However, I saw also some of them that they form groups. So for example, here there are 2 together. Yeah. And here they are not, and this one seems to be almost attached to each other. Here you have you see some that are not attached, but they seem to be in a group. I don't know how to, I don't know if it's important to differentiate, to make a third group or no, but I propose to make a group that are individual and one that is a group 1 and a group 3. And I'm going to tell you what is these 3 groups. So the 3 groups are the individual ones, are close, are alone, and there is nothing close to each other to them in 20 micrometers. And I will show you how to measure 20 micrometers. Yeah.
Okay.
So if you see here, there is no dots. The other ones are the ones that are not completely attached, but they in less than 20 micrometers, they are together. They are separated by only less than 20 micrometers. Yeah, so they are not super close, but there is a small distance.
Okay.
And finally, the red group, that is the one that appeared, that is a bunch of cells all together, a bunch of green spots all together. And I thought that maybe later we remove this definition, but maybe as a starting point, we can create these 3 types of cells and we can start quantify them. So for example, here I wanted to know if they appear at the same time, if one appear at a different time, and maybe we will start finding pattern by just labeling. And I thought that I was going to say to you, just count them, but maybe if we label it, it will be easier, because maybe we realize that that we want to change something, and if we have the label, we say, oh, this is actually 2, instead of recounting everything. I think it will in the beginning, and it will give us a better understanding of what is happening.
Okay.
So you will go through time and try to identify these 3 groups. Yeah. Yeah.
Yeah.
And the idea is that we will make a figure like this: the number of spots and the time in minutes. And I made up this term that later we correct. That is time after the removal of the peripodial membrane. I just made it up before the peripodial membrane. Later I will show you the movies. There is no spots in the movies.
Okay.
And I didn't send you that movie because it started developing and it started moving the legs too fast. So they are not pretty. And in the beginning, I think it will cause more confusion but later we can go through that. So we can see, for example, if maybe the spots appear more at the end when the tumors are breaking, or maybe they can happen. Every movie could be different. We can see if maybe the groups, maybe there is a peripodial membrane and all of them appear in the middle of the movies or not. We can test hypotheses like this.
Okay.
And I will send you an initial movie that I start doing that. Here I'm going to send you how to set a scale bar. Yeah, so this is, here is 20 micrometers. Yeah, and when you make a movie, the microscope will really give you that information. Good. So
yeah.
I just recorded, and I am going to send a file that says scale bar. I'm going to show you later how to make a scale bar.
Okay.
But the idea is that this is 20 micrometers, so you can, if this is 20 micrometers, you can make a line in image J and move it, drag the line. And for example, here, this is 20 micrometers. You can or you can just measure in the distance here. And this is, if this is 20 micrometers, image J will tell you that this is 8 micrometers. So the distance they are relatively close.
Okay.
While this one, if you, here are the 20 micrometers, and I make close here in the radius of this, there is nothing. So if you 20 micrometers here, 20 micrometers in this direction, 20 micrometers in this direction, there is nothing. Yeah, and this is just a fast way to try to test if there is just try to divide them. I don't know if it's a good way or not, but we can start giving some organization to what is happening.
Okay.
And then you can start labeling, like time 1. Here you have 1 yellow, no 0 red, and 0 blue. Here you in time, for example, you have 1 and 2. In time 3 you find 1 and 2. Yeah, no green and no red. So
yeah,
the graph would look like this. In the beginning there was nothing in the time 1, then in time 2 there were 2, and then they reduce again, and we can start doing something like that for the movies. I'm going to send you the movie that I already started doing that.
Okay.
And in that way, the idea that you can make a figure that could be the first figure of your paper. Let's say what happened. We're trying to evaluate says what is the distribution of these things, of these spots, and we divide it into 3 groups, and we find that we don't know what we find. We will see, but we can make a diagram. So this will be our temporal distribution. Okay.
Okay.